A very warm welcome to all of you. I thank you all for joining us today. The assessment of dynamic groundwater resources of India is conducted annually, and the same utilizes a GIS based web application known as INGRES. However, groundwater still continues to be a major issue due to the sheer size of the database and it being organized in a haphazard manner. This is what our team, CodeXCrusaders, aims at mitigating via the development of an AI driven chatbot, Varuna, a virtual assistant that should provide not just multilingual access, but the utilization of vector database to incorporate the historical reports with their retrieval via the LangChain RAG pipeline shall allow it to deliver accurate responses. Let's delve in deeper by taking a look over the prototype, furthering by analyzing over our innovations and the technical stack employed. This is the developed prototype for our chatbot, Varuna. Upon scrolling down, it gives a detailed explanation of the features employed. A chatbot incorporates the original INGRES database for 100% accurate and contextual responses. Upon logging in, one can see the dashboard showing the number of areas corresponding to the groundwater limits. In order to use the chatbot, one can easily either use the quick actions tab or type a prompt manually, as I am doing right now, for the groundwater resources of Telangana. Upon analyzing over the prompt, the chatbot will display the relevant data corresponding to the prompt as well as inferences that it can draw from the same. It provides a complete overview as well as a summary for the provided query. For the second prompt that I am giving for providing me a visualized analysis of the data for groundwater extraction for Telangana, the chatbot will take time to analyze and then, via the showcase of graphical representation, it shall answer us. This allows the chatbot to have a much more congenial as well as comprehensive build. As already mentioned, since the data employed comes directly from Ingress, we can ensure 100% accuracy and no hallucinations. The assessment unit staff provide an overall overview depicting the areas, their type, and groundwater status level. Not only that, it shows the current recharge, amount extracted, and the extraction safe limit. And this allows for the area's accurate classification on the basis of current recharge level. One can easily surf over the safe, semi-critical, critical, and overexploited tabs to get an overview for the areas. This comes in very handy when we shall have a very large dataset. The visualizations tab. This provides detailed graphical representations for the same numeric values that were shown in the assessment score. The graphs being interactive allow our bot to be much more feasible. Historical trends provide predictive analysis for the near and upcoming future, allowing for better research work as well as policy planning. This is one of the most pivotal points of our self innovations. Redis powered smart caching, as evident by our query history column, shows how a model can provide faster information access and reduce high database costs to a very small minuscule. To explain our technical approach, let's go over a simple flowchart. So basically what happens is that first the query from the user is received by the front end, which is built via React. It is then passed to the backend server built using the Python-based framework Fast API. From there, the query is translated and routed into a retrieval augmented generation pipeline powered by LangChain. Within this pipeline, the query is converted into vector embeddings and used to fetch relevant unstructured data from quadrant vector database. If structured data is required, the system automatically retrieves it from a PostgreSQL server where all the data from Ingress is stored in a tabular format. The retrieved data, along with the user's query, is then passed to the large language model, which generates a response based on the combined information. Finally, the LangChain memory is updated. The conversation is stored in MongoDB for persistence and also cached in Redis for faster access in future interaction. A brief overview of our code base. We start by collecting Excel sheets from Ingress as structured data and a GC user manual as unstructured data. In this file, the unstructured data is converted into vector embeddings and stored in quadrant DB, while the structured data is stored in a tabular format within a PostgreSQL server. A chatbot powered by Gemini as a LLM processes user queries by retrieving the most relevant unstructured data and simultaneously generating SQL commands to fetch the required tabular data. Combining both sources, the chatbot delivers a well informed and accurate response. That is all about Varuna from our site, Team Codex Crusaders. I thank you all for your time.